In this video, I'll go through the process of demonstrating how to balance a chemical equation. So recall the law of conservation of mass, also known as the law of conservation of matter, tells us that atoms are neither created nor destroyed. So whatever you start with, you must end up with the same thing, although they will be arranged differently. So in order to balance a chemical equation, you want to use coefficients, and those are the larger numbers written in front of the chemical formula. They indicate how many of those moles are present, or how many molecules or formula units, if it's an ionic compound, are present either as a reactant or a product. So I'll go through and demonstrate this process. So in the first reaction, you have nitrogen plus hydrogen to form ammonia. What I like to do under my reaction arrow, remember that's what separates your reactants from your products, I like to write the atoms that are present there and just dashes to the left and to the right. That way I can keep track of what's on my reactant side and my product side. These subscripts indicate the number of atoms in that molecule or that compound. So on my reactant side, I have a total of 2 hydrogen and 2 nitrogen. On my product side, if you don't see a subscript, that means that there's only one present, so I have 1 nitrogen and 3 hydrogen. Right now my atoms are not balanced, so I have to add coefficients, which you can think of as multipliers, in order to balance the equation. In this case, you have nitrogen and hydrogen each in one component on the reactant and the product side. If you didn't have that, there are little tricks, but we'll do another example in a minute. So in this case, it doesn't matter which one you start with. Neither one are balanced, so you can start by balancing either one. So if you look, you have 1 nitrogen on the product, 3 hydrogen. So I know I can multiply this by 2 to give me a total of 2 nitrogen. So if you want to look at what that would do, if I added 2 as a coefficient, that's going to change the number of nitrogen and hydrogen. Adding that 2 as a coefficient is essentially the same as me saying I have NH3 plus NH3. So I have 2 of those molecules. So that will change the number of nitrogen and the number of hydrogen. You want to keep track of these atoms as you go through the process. So that means that now I have a total of 2 nitrogen and I have 6 hydrogen. So your nitrogen atoms are balanced, but your hydrogen is not. I have more on the product side than the reactant side, so that means I need to go to my reactant side and add a coefficient. So I have H2 as my molecule. So think, is there any number that you can multiply this by to get 6? And of course 3 would be that number. So 3 would be your coefficient. When you add that, because only hydrogen atoms are in that molecule, only hydrogen atoms would change by adding that coefficient. So that 3H2 is essentially the same as me saying H2 plus H2 plus H2. So I have 3 of them for a total of 6 hydrogen atoms. So right now, everything is balanced. So if you don't have multiple of a molecule or a compound, no coefficient is needed. Now in this worksheet, if you're asked to fill in the blanks, then you would just put in a 1. But if you're writing out your actual formula yourself, you would not show that 1. By simply writing that formula, we know that 1 is present. So let's try another example. Let's go down to, we'll just do number 6. Something that involves multiple atoms. So AlBr3, K2SO4, those are my reactants. They're reacting to form KBr, as well as aluminum sulfate. Now there are different ways that you can do this, so I'll just cover up this other worksheet so it's no confusion. There are different ways you can do this. You can look at the type of reaction. You can see that these 2 reactants both swap partners, so that's a clue that you're dealing with a double replacement or double displacement reaction. And so when you're dealing with double replacement or displacement reactions, those ions stay together. So if you started with sulfate, you still end up with sulfate. So I could balance the number of ions present. So I can balance my aluminum ions. I can balance the bromine ions. I can balance the potassium ions. and I could cheat and balance the sulfate ions. So I didn't put charges for the others, but I'll go back and do those. So you could do it that way, or we could still stick with the individual atoms. Both will give you the correct answer. For double replacement reactions, sometimes it's quicker to just leave those ions intact, but if you want to go through and look at the individual atoms, you can do it that way as well. So for this example, I'll just show you leaving those ions intact. So on the reactant side, we have 1 aluminum ion, 3 bromide ions, and I'm simply getting that from the formula. We have 2 potassium ions, and we have 1 sulfate ion. Product side, we now have 2 aluminum ions. We have 1 bromide ion. We have 1 potassium ion. We now have 3 sulfate ions. So if you look, none of these atoms are balanced. Again, each exists in only one compound on the reactant side as well as the product side. So it doesn't matter which one you start with. So if you wanted to start with, for instance, the aluminum, since we wrote it first, we have 2 on the product side, but only 1 on the reactant side. So I can add a coefficient of 2 on my reactant side. Adding that coefficient is going to change the number of aluminum, but it also changes the number of the bromide ions. So I now have 2 aluminum. I now have a total of 6 bromide. Because remember that coefficient of 2 is the same thing as me saying AlBr3 plus AlBr3. And so now my aluminum are balanced, but again, nothing else is balanced. So let's say you want to go and balance, since the bromine is next, we can go and balance that bromide ion. We have more on the reactant side, so therefore we need to add our coefficient to the opposite side, being the product side. I only have 1 on the product side. If I look my subscript, there's nothing written, so there's only a subscript of 1, an invisible 1. And so think about what can you multiply this by in order to have the same number on both sides of the equation. So of course 6 should come to mind. By adding that coefficient of 6, it changes our potassium and our bromide ions. I now have a total of 6 potassium ions and 6 bromide ions. At that point, your aluminum and your bromide are both balanced, but the potassium and the sulfate are not. In both cases, you have more on the product side than your reactant side. So that's a clue that you want to go to your reactant side to add the coefficient. And so we look at the potassium first. When I look at that potassium in this compound, I have a subscript of 2. So when I add a coefficient, I have to keep that in mind because I'm not just multiplying that number by 1, I'm actually multiplying that number by 2. So if we go and add a coefficient of 6, that's going to be 6 times 2. So you don't want to do that. You want to add a coefficient that when multiplied by 2 would equal 6, which of course would be 3. So adding that coefficient in front of that compound changes your number of potassium and sulfate ions. I now have a total of 6 potassium. So I'll write this one out just to make sure everybody's with me. 3 as the coefficient indicates that I have K2SO4 3 times. And so because I have it 3 times, I have 2 potassium here, 2 here, 2 here, for a total of 6 potassium. Or I could have simply looked at this compound has K2, so now that I have 3 of them, 3 times 2 gives me 6. But I also need to look at my sulfate. I only had 1 sulfate in my reactant. Now that I have a coefficient of 3, I have a total of 3 sulfate. So at that point, the aluminum, they're balanced, the bromide is balanced, potassium balanced, sulfate balanced. So we have a balanced chemical equation. So when you're balancing chemical equations, sometimes it takes a little more effort than others, a little trial and error, but you want to make sure that as you're changing your coefficients, go ahead and change how it affects the atoms that are present so that you can keep track of what you have and what becomes balanced and what still needs to be balanced.